Hi, Gus. Today's lesson is about distance time graphs. So if you look at this result table, it shows the journey of a car at 3 different times. So let's first of all look at journey number 1. So this is the time. So after time, at time 0, distance was 0. And after 1 second, car had traveled 7 meters. After 2 seconds, it was at 14 meter mark, 3 second, 21, and so on. So we can see from here that every second car was traveling 7 meters, or we can say that speed of the car was 7 meters per second. So we can figure out the speed from the information, or it will be easier to actually draw a graph. So if we draw a graph, if you look at the middle one, so after 1 second, it had traveled 7. After 2 seconds, it had traveled 14, which is a 14 meter mark. And then 3 seconds, it's 21 meter mark. So we see the shape of the graph as a straight line. So in a distance time graph, if a graph is a straight line, that means that car was traveling at a constant speed. And how do we find the speed from this graph? We find the gradient. And what is the gradient? Gradient is rise over run. So that's the rise and that's the run. So if we look over here, that distance from here to there is 70 minus 0. So the rise is 70. And if you look over here, the run is from here to there, that is 10. So 70 divided by 10 gives you 7 meters per second. So if we want to find out the slope or gradient of a straight line, that for this one, it comes out 7 meters per second, or we can say that gradient of a graph gives us the speed of the moving object. So this car, at this time, it was moving with a constant speed. Let's look at the second information. So second time, car travels, and first second it travels 2 meters. Then after 2 seconds, it was 5 meter mark. So from 2 to 5 is the distance of 3. 5 to 9 is the distance of 4. And then 9 to 14 is the distance of 5. So that means in first second, it travels 2 meters. Then it travels 3. Then it travels 4 and 5. So car was traveling more distance every second. That means car was speeding up, or we say the car was accelerating. And this path, initially, first second it travels 12. Then second it travels 23 minus 12 is 11 meters. And then next second it travels 33 minus 23 is 10. So every second it is traveling less and less distance, or we say that car was slowing down, or it was decelerating. Now, if we plot this information on the same chart, it looks like this one. So as you can see from here, it's a curve, and it's an upward curve. And if you look at the steepness of the curve is increasing, or in other words, gradient is increasing. And because gradient represents the speed, that means speed is increasing. So this one is when a car is accelerating. The third information which we saw here, if we plot this one, we get this green line. So in green line, the curve is a downward curve. So a downward curve means that car was slowing down because the slope is decreasing. It is becoming less and less steeper. So to summarize that one, a straight line means it's a constant speed. An upward curve means it's an acceleration or constant acceleration. A downward curve means it's a deceleration. Say, for example, there was a car which was initially at, say, 50 meter mark, and then it doesn't move. After 2 seconds, it is still at 50, 50, 50. So if we draw a line, it will be like a horizontal line. So horizontal line in a distance time graph means that the object was stationary, it wasn't moving. So this is one of the sheets that you have to complete in today's lesson. Let's look at the another one. So now you see these are your notes. So there are some videos listed here that you must watch and try to explore these animations here. So what we are saying over here is that a straight line means constant speed. If a line is this shape, that means a stationary object. Now, an upward curve means an acceleration. A downward curve means a deceleration. We haven't discussed this one, but here slope is constant. So we say it's a constant speed, but because slope is negative, this one is a positive slope, this one is a negative slope. So that means the car was moving at a constant speed, but it was coming back, or it was moving in the opposite direction. Now I will show you that, but before I move on to that one, you have to complete this quiz and you have to complete this worksheet, which is posted in Google Classroom, and also that one. But I want to show you this animation over here, which is over here. Okay. Now, so again, that's a distance time graph for this car. But now what you will see is that you note down the speed of the car, and then as the car moves, it traces this one. So it will tell you that this one, if this is a straight line, that means a constant speed, and you will see the car moving over here at a constant speed. So let's start. So car is moving at a constant speed up to 400 meter mark. And now it is stationary. So time is passing, but car is stationary. So that's how the graph looks like, horizontal line. Now this is a negative slope, and the car reverses. It's moving at a constant speed, but it's coming back from where it started, or it's moving in an opposite direction. Okay, let's reset it. Now have a look over here. And this part, gradient is a steeper line, or gradient is higher. And this one, it is less steep. So that means in both parts, it's moving at a constant speed, but this one is a slower speed because the slope is smaller, or gradient is less. So have a look one more time. So constant speed. So just have some idea of the size of the speed. Then stationary, car is stationary. Car is going backwards at a constant speed, but this one is slower than initially in this part. Okay, one last thing. If we want to find out the speed from a distance time graph, we calculate the gradient. So gradient is rise over run. So this part over here is 400 minus 0, 400, and time is 15. So if we have to calculate the speed, it will be 400 divided by 15 seconds, and whatever the answer comes, so that will be the speed. So thank you for watching the video, girls. So that's all for today's lesson. I will stop.